Assalamu alaikum. This is chemistry 12th, and our today's topic is coagulation, or also we call it as flocculation. Now, before going through this topic, I would like to give you a recap of what we have discussed in this chapter. Since we are discussing this surface chemistry, we have discussed various types of these various methods for the synthesis of these colloids. We have discussed Brownian moment. We have discussed protective colloids. Now, our today's this topic is this coagulation. Now, dear students, you already know that the two types of colloids. We have lyophilic and lyophobic colloids. Now, as you already know that these lyophilic colloids, they are stable and self-stabilized. On the other hand, we see these lyophobic colloids, they are not stable, so they require traces of electrolytes for their stabilization. Now, as you know that these lyophilic colloids, they are we can say now that these lyophilic colloids are stable. They are stable than lyophobic colloids, and these lyophobic colloids being unstable, they require traces of these electrolytes for their stabilization. Now, the ions of the electrolytes, which stabilize these lyophobic these colloids, they get absorbed on the solid particles and impart them some charge, which may be positive or negative. Now, these charged solid particles, these charged solid particles, they repel one another and prevent them from coming closer to form aggregates or to form bigger particles. Now, the ions or the electrolytes, these ions of the electrolytes which cause stabilization of these colloidal solids, they form a protective cover or an envelope around these around the solid particles. However, in presence of excess of electrolytes, or if excess of electrolyte is added to these colloidal solids, the charge on the solid particles gets neutralized, and as a result of which they come closer and grow in size and ultimately form precipitates. Now, as far as this topic, that is coagulation, is concerned, this coagulation, it is the process of precipitating the particles of the dispersed phase from the colloidal or we can call it the process of this precipitating the particles of the dispersed phase from the colloidal sol is called as coagulation or flocculation. Now, we know that in a colloidal solution, the particles of the dispersed phase, they carry same type of charge. They may carry either positive charge, or they may carry a negative charge, or we can say that we may have a negatively charged sol, or we can have a positively charged sol, because the charge on the particles of the dispersal phase is same. It is not opposite. Now, because of the presence of the same charge on these solid particles, of the solid particle of a particular sol, they repel one another and are kept apart due to the repulsive forces, and these forces, they are responsible for the stability of these colloidal solids. Now, if the charge on these colloidal particles is somehow neutralized, the small particles come closer, they stick together, forming aggregates or bigger particles, and ultimately cause their coagulation. Now, you see just here how these ions, they they get absorbed on these salt particles, rather than forming a protective cover, or forming and just like an envelope. Now the same is with this salt particle, because of the presence of the same charge around this salt particle and around this salt particles, around this salt particle, these charged salt particles, they now repel one another, and does not come closer, and thereby providing this stability to this colloidal sol. Now as far as coagulation is concerned, the ions that bring about the coagulation, or that bring about the precipitation or flocculation of these colloidal sols, they bear a charge opposite to that of the colloidal sol. For example, we see barium ions being positively charged, they bring about the coagulation of a negatively charged sol, like arsenic sulfide. This barium chloride, it upon ionization, or it dissociates, giving divalent this barium cation, and chloride ions. Now see, since this arsenic sulfide is negatively charged sol, and barium ions being positively charged, they cause the coagulation of this negatively charged sol, that is arsenic sulfide. Now when these barium ions, when they are added to this arsenic sulfide salt, the negatively charged salt particles of arsenic sulfide, they are attracted by barium ions, thereby neutralizing the charge on them. Now, what is the result? The result is that the repulsive forces between the salt particles of this arsenic sulfide, or between the arsenic sulfide particles, it gets vanished, and precipitation results. So what we see here, it is the positively charged ion that brings about the coagulation of a negatively charged salt. Similarly, a negatively charged ion can bring about the coagulation of a positively charged sol. Now the coagulations, as you know that now the positively charged this sol can be, now can the coagulation of this positively charged sol, since As2S3, that is arsenic sulfide, is a negatively charged sol. Similarly, a positively coagulation of the positively sol can be brought about by the addition of negatively charged ion, like we have got this positively charged sol, like ferric hydroxide, that is a positively charged sol, and its coagulation can be brought about by the addition of a negatively charged ion. Now the precipitation action, say, see here, it is due to the addition of these electrolytes to these colloidal sols, that this coagulation is brought about. Now, as far as these ions are concerned, which bring about this coagulation or precipitation, the precipitation action of an ion, it depends upon the valency. So greater the valency of an active ion, greater is its precipitation action. So there is a rule we call, that is a Hardy shoes rule, which says that greater, which states that greater the valency of an active ion, or greater will be its precipitation action, or and it will the greater the precipitation will greatly the precipitation will take place. Now the coagulating power of different ions, of different cations, as I have shown here, in decreasing order of their coagulating power. See here, we have got aluminium is a trivalent positive ion, so its valency is greater. Than we have got the magnesium, which is a divalent cation, and sodium, which is a monovalent. So this is the coagulating power of these different cations in descending order. Similarly, the coagulating power of different anions in decreasing, or in descending order is shown here. We have this is hexacyanoferrite ion. It is a tetravalent, and then you got this this is a phosphate, this is trivalent, this is anion, then you got sulfate, this is divalent anion, then you got the chloride ion. So this is the precipitating or the coagulating power of different ions in decreasing order of their coagulating this precipitating action. Now the minimum concentration, now we see there, it is with the addition of these electrolytes that coagulation can be brought about. Now the minimum concentration of an electrolyte which is required to cause the coagulation or flocculation of a sol is known as the flocculation, we call it as flocculation value, and it is expressed in millimoles per liter. So this is one method of bringing about the coagulation of these, bringing about the coagulation or precipitation of these colloidal solids. Then another method we have got, that is aging process. So what happens in aging process, if a colloidal sol is left undisturbed for a very long time, now with the passage of time the colloidal particles get together, they get together forming bigger particles or aggregates which settle down under the action of gravity and thus bring about the coagulation or flocculation. Then another method of bringing about the coagulation is we have got the mutual coagulation. What we do in mutual coagulation, the coagulation of a sol can also be brought about by adding an equal amount of oppositely charged sol. For example, the coagulation of arsenic sulfide sol, which is a negatively charged sol, it can be brought about by the addition of a positively charged sol of like a positively charged sol, that is a ferric hydroxide. So when it is added to it, the coagulation of these negatively charged salt, that is arsenic sulfide, can be brought about. This is for today. Thank you very much.